Okay, so welcome back to the FuturePrint virtual conference. And FuturePrint's very much about where print technology is going in the future. And obviously we have with us today this session, which is really pushing the boundaries of what's possible. And it really is where the industry is going next with this sort of cutting edge technology of inkjet. I'm joined today by Graham Tweedale, the General Manager at Xaar. Xaar, one of the leading, or if not the leading, independent manufacturer of inkjet technology. And he's joined by Kate Black, who is the founder and the CTO of Meta Additive, who are doing some really incredible and exciting things with inkjet, with additive manufacturing, I believe, within automotive, aerospace, and medical. But Kate's going to explain more about that. So welcome both to the event. Really excited about hearing everything you have to say. So really, without further ado, I'd like to, I think, hand over to you so you can begin your story. Graham, I believe you're first.
Thank you, Marcus, and hello, everybody. Okay, so pushing the boundaries of what's possible with inkjet. And first of all, I want to talk a little bit about innovation. And innovation has always been at the heart of Xaar. And it was in the late 1960s that our original drop-on-demand technology was invented by Steve Temple and David Payton, who were at Cambridge Consultants at the time. And they were asked by a client to find a better way to print their carpets without touching the material. And as a result, they started looking at the physics of droplet ejection from nozzles. Then Xaar itself started life in 1990 with 4 granted patents and 84 patent applications pending. And since then, we've filed more than 2,000 patents, and we're still inventing today. So innovation is in Xaar's blood. And last year, when we rebranded the company, we changed our values to put innovation and creativity front and center of what we do. And we recently asked some of our colleagues to share their experiences of the values and what it means to them personally. Renzo Tripp, one of our principal engineers, made the comments that you can see in the slide. And I think what he says reflects well the collaborative way in which we work at Xaar. So a little bit about what drives that innovation. So our leadership style is to empower our employees to make decisions and take some risks. And from the top down, we have a commitment to innovation. We invest over 10% of our revenue into R&D in the printhead business annually. We also have a specialist team focused on advanced applications and technologies. And our collaboration with Meta Additive is a great example of how this team explore what's possible with inkjet and the new applications that we can enable. We have dedicated cross-functional teams for our projects that have access to all of the resources across the company. And these teams are flexible and agile, and importantly for our people, they're doing really interesting and engaging work. And with our values and our culture, we encourage people to take ownership and show the passion they have for innovation. We foster a supportive environment where people can develop and learn. And our values focused on creativity and innovation, and we reward people for living by them. In fact, part of our performance review process looks at how well we live by our values. And diversity in our culture is also really important. We have over 23 different nationalities at Xaar and many different languages spoken. So collaboration, discussion, and teamwork is key, not just within Xaar project teams, but across the company, and particularly with our customers and partners. And you'll see an example of collaboration in a moment from Kate. So next, a bit about the technology. So Xaar's bulk printhead platform incorporates a number of innovative technologies that push the traditional boundaries of inkjet. From printing vertically, printing on curved surfaces, to jetting fluids with high particle loading, the technologies that we have expand the range of applications that inkjet can address. So let's take a look at those core technologies. First of all, TF technology. So when Xaar's first recirculating printhead was initially conceived, the architecture was fundamentally designed to create the best possible inkjet recirculation system. The design of the printhead is unique, such that fluid flows directly past the back of the nozzle at very high flow rates. This, combined with an open and symmetrical architecture, means you don't get dead spots in the fluid path where pigments and particles can collect, which would block nozzles. This unique capability separates our technology from other flow technology and has helped transform a number of industries and support many applications with challenging fluids, including meta-additive. The nature of true through-flow architecture enables fluid movement through a channel even when it's not jetting. Whereas other architectures, if you're not jetting, the channel is dead space and you get agglomeration and sedimentation, which can block nozzles. So some of the benefits our partners see when using Xaar's TF technology are maximized uptime, helps to reduce cost, increased nozzle open time and reliability, and a wide operating window that allows jetting in any orientation with challenging high viscosity and high particle loaded fluids. And last year, we released a white paper on our TF technology, which includes some results from a number of controlled experiments that demonstrate the benefit of true recirculation. So if you're interested in finding out more about TF technology, please use the QR code on the slide. High laydown technology. So high laydown mode is a single cycle print mode that allows for very efficient high pumping capacity of Xaar printheads. This high laydown capability exists in all of our main printheads, so the 1003, the 2002, and the 501 product. And the same printhead can print high definition, as well as high laydown haptic effects and textures without needing a different product. High laydown technology increases productivity of the printhead 5 times. So one printhead can jet an impressive 11 liters per hour in high laydown mode. And high laydown is a very versatile technology. It enables OEMs to design machines that add value to products, from making packaging more appealing with haptic effects, to providing a digital method of printing braille, to adding design effects to ceramic tiles. And high viscosity capability. So typically inkjet is limited to a maximum fluid viscosity of about 25 centipoids. However, Xaar's unique high viscosity capability means we can jet fluids over 100 centipoids. And this capability enables the use of materials and chemistry that's not seen in other inkjet technology. So what does that mean? What are the examples of what we can do? Well, we can jet a wide range of high viscosity fluids, which in additive manufacturing provides increased toughness and flexibility of photopolymers. We can jet highly pigmented, high density and high particle loaded fluids, which increases the color gamut for graphics inks, enables us to jet a wide range of functional fluids in display panels, printed electronics, and glass applications. So now I'd like to hand you over to Kate, who's going to talk to you a bit more about meta-additive and their binder jetting process.
Thanks, Graham. So as Graham said, I'm from meta-additive. I'm actually the founder and CTO of Meta. Meta was founded back in October 2019, and it was actually a spin out from the University of Liverpool, where I'm also a senior lecturer in the School of Engineering. So although I work in engineering, my background's in chemistry, and this is really where the foundations of Meta's technology came from. We use a tailored chemical approach to tackle some of the issues currently found in existing additive manufacturing technologies, such as the limited palette of materials, high shrinkage rates, low processing throughputs, and poor densities. But how is it different? Well, let's first look at the conventional binder jet approach. So we see a schematic on the slide here, and conventional binder jet usually has these 4 or 5 steps. And we have a powder bed that could be a metal or a ceramic, and we use an inkjet head to deposit a polymer binder. And that binder is usually a sacrificial binder, and that's key to the difference between our technology and conventional binder jet. So we use the inkjet printer, print down the binder, and we repeat this process layer by layer to get your 3D component. But because the polymer is a sacrificial binder, it needs to be debinded. This can be quite lengthy. It can add carbon into the film, which presents many challenges when you're trying to process metals. But also it limits the size of the components that you can print. If they're too large, then you can't get the polymer binder out of that component. So it's limiting the size, it's limiting the complexity of the geometry that you can print. But because you have to debind and then do a sintering step, you see large amounts of shrinkage rates. So you've also got to either predict how it's going to shrink, or you stick to straightforward, smaller, less complex geometries. And we also see sometimes for certain applications, we need this fifth step, which is an infiltration step, because there's some residual porosity left over in the component. And this ranges depending on the material you're using, but it can be as much as 20% porosity there, which is obviously isn't ideal, particularly when you're using them for applications such as automotive or aerospace. So you need this infiltration step. So the actual printing process itself is quick, but this debind, the heat treatment step, the infiltration step is limiting the processes which you see binder jet being used in. So Meta came from this from a different angle, and we used a chemical approach, as I said at the beginning. And we can see that limits this step down to 3 steps. So you have your usual powder that you layer upon, you use an inkjet head, and we'll come on to those shortly, but you use those inkjet heads to print what we call a functional binder. And we are binding and simultaneously infiltrating our powder bed. So there's no debind step because we're not using polymers, we're not using a sacrificial binder, we're using a functional binder. And that binder contains an organometallic or a molecular component to the ink. That's a solution-based. When that sees the powder bed, it forms a lovely conformal coating of either metal or ceramic, depending on the material that you use. And that lightly holds the powder together. It actually reacts the powders together. So you get a proper chemical metallic or ceramic bond forming, and that holds it together. And held within that molecular component, you also have nanoparticles and micron particles. And they help fill in some of the interstices or the pores of the powder bed. The nanoparticles also help to lower the processes which you need to do a heat treatment step after. So there's no debind step. You can shorten some of the processing times. But on the next slide, let's have a look at some of the other benefits to the Meta technology. So this chemical approach allows us to have much lower temperatures. So sometimes we can cut the processing temperatures down by around 300 degrees. So we can lower the thermal budget because the organometallic fraction of the binder, if you like, has its heritage from low chemistries, low temperature chemistries, things like ALD, CVD chemistries. And the fact that you're not having to do a debind step also lowers the temperature. The fact that you've got nanoparticles infiltrated into your powder bed from the binder also means that we can lower the post-processing temperatures that we use. Much higher throughput rate, so it's actually 30 times faster rather than conventional metal processes. When we look at conventional laser-based AM processes, this inkjet process, this binder jet process can be much faster, but it can only be faster if we can get rid of that debind step and those unnecessary lengthy heat treatments. And this is what the Meta process allows us to do. And because you're binding and simultaneously infiltrating with build material, you get much higher densities. There's no sacrificial material that you're having to take out. You're filling that powder bed with wanted material, with build material. And that allows us to get green part densities. So they're the densities of the part as soon as they come off the printer. Anything from around 40 to 75%. So if you look at conventional binder jet, you're usually looking at densities of around 40, maybe 50 at the most. But we can get up to 75% for our green part densities. And then if we do a heat treatment, we can go up to almost 100% density. And that's because of this infiltrating with build material. What you conventionally see with normal binder jet is these large amounts of shrinkage rates. And that's due to the fact that you've had to extract some of that material. that polymer material that was binding the powders together in the first place. And what we see with the Meta process is we reduce that shrinkage rate from 20% to 2%. So if you can do that, you can start printing much more complex geometries than you conventionally would. And because you've got pre-reacted material, as soon as you've printed, you have much stronger green part components. So we can print larger components as well. And this just opens up the avenues and the sectors that we could use binder jet printing in. But I think for me, what's the most fascinating is the fact that you've got build material in your inkjet head, you've got build material in your powder bed, and that powder bed could be one material. That organometallic fraction of the binder could be another material, the nano another material, the micro another material. And then you can start to see how we can build up truly multi-materials on additive manufacturing for the first time, properly for the first time. So there's many benefits for that. We've covered those, but none of this would be possible if it wasn't for certain collaborations. And that brings me on really to the collaboration that we have with Xaar. It's all to do with collaborations. None of this would be possible if we didn't have the right print head. And we struggled for this for a good couple of years, actually. We had binders that we knew could work, the chemistries worked, but we couldn't get a reliable head to jet our technology, to jet our binders rather. And this is where Xaar comes in. So we've been collaborating with Xaar for about a year. I met one of the team at an inkjet conference at the beginning of 2020, and it's really blossomed from there. And why we went with Xaar was because, well, first of all, they had a reliable head technology, and this is crucial for us. If we want to turn this into a mass manufacturing process, which we can do if we get rid of these unwanted debind and heat treatment steps, we still need heads that can perform reliably. And Graham talked a little bit about that technology at the beginning, this high flow throughput, the high viscosities, ability to handle large quantities of particles. And so this is what first attracted us to Xaar and their head technology. But it wasn't just that. Collaboration and making headway in technology, whether it's AM or any other technologies, is about clear and open communication. And that's what Xaar allows us to have. They've got this long-term thinking. It's not just the here and now, right, we'll sell a couple of heads, that's us out of the way, we've done our job. It was much about how can we grow with these companies to collaborate and to develop our technologies further. Many of the head technology companies that we went to previously were said, well, you're going to have to modify your binder to fit our head. It was never, let's meet in the middle. And that's what we liked about Xaar, is it was very much let's meet in the middle. We think we've got a good technology to start with. It'll get you a long way, but we'll work with you as your technology develops to improve ours and see whether we need any other systems that might modify that. And so that's what we're doing at the moment. So it's that adaptability to come to a customer like ourselves and say, okay, yeah, we're prepared to work with you. And it is that collaboration, I think, that's allowed this technology to go on leaps and bounds. And I'm really hopeful for the future because of that. We have a strong partner with Xaar that will allow us to do all the crazy, wonderful things that we'd like to do with our materials. So I'm going to hand you back over to Graham, and he's going to talk to you a little bit more about the future of Xaar and what they're going to be doing.
Thank you, Kate. So what about the future? Well, our TF technology, high laydown and high viscosity capability are still at the heart of our technology and our customers' own innovations. So these three technologies will continue to be relevant with our new ImagineX platform that we announced last year. And in addition, we're adding fantastic new capabilities. So speeds up to 150 kilohertz, increased resolution up to 1440 DPI, and the ability to jet all ink types, including aqueous. And I'd like to share with you some progress that we've made. So back in September, John Mills, our CEO, shared our roadmap, and we've made great progress. So in the first half of this year, we'll be launching a new product with a 40% increase in print frequency And we're building the alpha samples for our first aqueous compatible printhead and alpha samples of printheads with increased drop throw distance. And we also have our ultra high frequency printhead now in test. So if anyone has further questions about our roadmap, I'd encourage you to please get in touch and I'll be happy to answer them. And finally, I'd like to say thank you. Thank you for listening. And thank you to Kate. We're really excited about the partnership and looking forward to working with you closely in the future. Thanks you.
Great.
Thanks, guys. That was very interesting. I've a couple of questions I wanted to kind of ask, and I'll start with Kate. You kind of touched on it already, but I'll just stick for my non-technical mind. So additive manufacturing doesn't only use inkjet, does it? There are different processes. Just cover again why inkjet's of interest to you particularly over these other like sintering and whatever. Yeah.
Okay, so well, we can. At the moment, additive manufacturing is still limited to batch production, small runs. It's a bespoke by nature, usually quite high cost. And if we really want to see how additive manufacturing could be in the future, we need to be able to create mass manufacturing with additive manufacturing. And at the moment, that's a slight oxymoron because they are still pretty slow. So they're usually based, particularly metal additive manufacturing is usually laser based. Most of the things you see in aerospace, automotive are these laser based, where they're laser onto a powder bed. They're costly. They're pretty slow. Okay, you add more lasers, make them faster, but you add the cost to that. And this is really one of the things why we haven't seen the uptake of metal additive manufacturing from people like the automotive and aerospace. Yes, they use it in their niche areas, but what if we want to see it for mass manufacturing and many more sectors? And that's why we chose inkjet, really, because of this fast throughput. You see the speeds that you get for graphical printing, meters per second. Can we make that a reality for metal and ceramic additive manufacturing? Probably not quite as fast, but I think we'll get there. But it's about limiting all those other post-processing steps that we see. And inkjet technology gives us that ability for multi-material as well. So you can have banks of different heads with banks of different binders, but different inks in there, all allowing to give different materials. Whereas if you're using a laser-based, even with a polymer or a powder-based system, you've got one vat of material, or you've got one powder bed of material. So you're pretty limited to the palette of materials that you can process with. Whereas inkjet gives that ability to, even on a Vauxhall level, I think that's as far as we can go. We'll start to be able to control the amount of material and the type of material that's jetted. And the fact that looking at, Meta's process is where you've got build material in your head and the powder bed. This is where we start to see some really fascinating things that could happen. So if you can start printing a component that has a ceramic, oxide, nitride, metallic in there, all in one process, just imagine the type of devices that we could print. We haven't even begun to think about how we could do that because the technology didn't exist until now. So I think it's... The short answer is it just gives us far much more flexibility, does an inkjet process, and the speeds that we need.
It's incredible, the versatility of inkjet, but you've also then in summary said things like speed, potential speed, quicker, economies, which is obviously an important factor, and also the variety. And so inkjet continues to push the boundaries, of course. With Xaar in mind, and perhaps you can just touch on this, Kate, and then Graham, please contribute as well. Xaar heads, what characterizations of Xaar heads were appealing to you, perhaps versus others?
Okay, so, the first thing was we needed a head that could jet particle or heavily loaded particle length. And that was a real challenge. And we did use some other head manufacturers, and it just didn't work. It wasn't reliable. The thing about the Xaar head is you can start printing, you could stop it, leave it over the weekend, start again on a Monday. There's no priming or anything like that. You press go and they start printing. And that's really crucial if you're going to have a true manufacturing process. You need it to be reliable. And the architecture of the head allows you to have much more heavily loaded particles and more viscous inks. So that's really what attracted to us. And the fact that they already exist, they're manufacturing them at scale, they're used in lots of other different technologies, other different sectors. And so there's a lot of know-how already about those heads that can be fed into our technology.
And when you say viscous, you're meaning thicker ink, in essence. Yeah. Sorry, Graham, you're going to contribute there.
Sorry. And this is what we see, Marcus. If anyone is trying to work with a more difficult or challenging fluid due to its viscosity and high particle loading and pigments, our through-flow technology copes with that extremely well. So you get the reliability, like Kate said, you switch it off over the weekend, you come back in on Monday and it will start up without having to purge and prime and have lots of intervention to get the printhead to work correctly. And that's really the core of the TF technology.
Yeah, that's where
another thing that's I should mention about Xaar heads is the fact when you're printing metals, particularly things like copper, which are highly conductive, that can present problems in other inkjet heads. It doesn't present the problems in the Xaar heads.
Right. Excellent. So you also mentioned, Graham, with your presentation, you talked about ImagineX. You also talked, both of you talked about collaboration, communication. So there's a human side to this, which enables that. And obviously, really, when you look at the fact, I think Kate, you mentioned you started talking at 2020 early. So actually, it's quite a rapid set of events in order to get to where you've got. So tell us a bit more, Graham, about ImagineX and that kind of cultural thing that seems to be appealing for Kate.
Sure. Well, and Kate said it. I mean, we're not focused on selling a small number of printheads. We want to understand what do we need to do together to make the application successful. So that may mean we do look at, we may need to modify a printhead in some way to better fit a customer's application requirements. We'll work with fluid vendors so that, we have fluids that fit appropriately for the application and for the printhead. So it's very much, an approach where we will customize, we will modify, and we will work with the partner to find the best solution for the application, not just, it's a printhead sale. We want to make that application successful. And that's the approach we take with all of our teams.
Brilliant. Well, thanks so much to both of you. Fascinating, really exciting as well. And something that clearly you've innovated through the period of COVID as well, proving that spirit of innovation continues. So appreciate both of your time. Very interesting presentation. If anybody listening wants to connect with Graham or Kate, they have profiles on the website, which they can do so at, and hopefully Kate will join us for our Q&A live later on. So thanks very much.